Alright, so far we've talked about scalars and vectors in a very generic sense. So as we work through units that we deal with and variables that we deal with in physics, many of them will be defined as either a scalar or a vector. Alright, and oftentimes they come in pairs. So distance and displacement are examples of scalars and vectors. Like a specific example. So distance is a scalar. You don't need to give a direction with distance. Alright, another way to think about it is it's always the total distance that you travel regardless of any turns. Alright, of any turns or changes in direction. Alright, whereas displacement is a vector, and for displacement you ignore the turns, or you ignore the total trip, and you want to focus on how far away. So instead of being confusing, let's talk about how far and in what direction you are from your starting point. Okay? So, how many turns you take, how many back and forth trips, things like that don't matter. It's where you are at the end and how far away that is from where you started. Okay, so apply that to a problem. So, Susie wants to go shopping at Caroland. She gets off of the 101 at Scottsdale Road, and she drives 3.7 kilometers south along Scottsdale Road. All right, and I'm just going to start highlighting some things here. We've got a 3.7 kilometers south to Greenway when she thinks, oh no, I left my wallet at home. So Susie makes a U-turn and goes north back towards the 101. But just before she reaches Bell Road, which is 1.5 kilometers later, all right, she sees her wallet sitting on the passenger seat. So at Bell Road, she makes another U-turn and returns to Greenway and goes shopping at Caroland. Starting when Susie gets on Scottsdale, what is Susie's total, sorry, there should be an apostrophe there, in there. There shouldn't be an S in there, sorry. What is Susie's total distance traveled and total displacement? And I apologize for my grammatical errors there. So let's make this a little smaller so we can have room for a picture. So let's draw some pictures for us. So let's say here we have the 101. Alright. Here we have Scottsdale going down. And let's call this right here Greenway. Alright. So this is north, this is south. And this is 3.7 kilometers. And we also are going to have Bell Road in here. Bell. And we know that from here to here is 1.5 kilometers. Bell Road shows up 1.5 kilometers after Susie has made her U-turn at Greenway. Okay? So, if you think, another way you can kind of think about this is we have, we don't even need to do that. So let's keep our picture like this. Now let's draw some arrows, draw in our vectors that indicate Susie's trip. So she starts here, goes all the way to Greenway, okay? And then she turns around and goes to Bell. And then last part, she gets back to Greenway. So all of those brown arrows are the vectors that we're dealing with, that we're adding, subtracting, that sort of thing. So, first thing is Susie's total distance traveled. This part's easy. Directions don't matter. It's the whole trip that matters. So our first vector is 3.7 kilometers. All right, our second vector is 1.5 kilometers. And our third vector is 1.5 kilometers. All right? So if we add that all together, you get a distance of 6.7 kilometers. So there's distance. All right. For displacement, you have to do the addition of the vectors. All right, so that's where, and I'm going to kind of redraw these so that we can see them in different colors. So here's our 3.7 kilometer vector. And then she goes like this, 1.5 kilometers. And then she does one more, 1.5 kilometers back down. Okay? So we need to know where our open tail is, which is going to be up here. And then our open head, which is the red one, which is down here. And we want to know this resultant. Alright? So despite the fact that she had some couple back and forth things, her displacement is from Scottsdale Road to her final getting to Greenway, which is 3.7 kilometers, and she was going south. Alright, so it's the same rules as what you do with scalars and vectors. Alright, this is just in a very, now we're kind of getting into, you've got to have units that are related to distance or length. Alright, and we'll get into more pairs like speed and velocity, alright, and other things that are vectors in one direction or another as we continue through this chapter and throughout the book. But that's the end.